Okay, we've come to the end, my friends. We are at the Unit 6 review. So we are reviewing everything. This is the introduction to integrals, antiderivatives, definite integrals, and U substitution. I think there is one tricky U substitution that I really haven't taught you that will be on the test that I think is on this review. And so there's a special addition to this review. So please pay attention to when I do that problem, and I'll point it out. Okay. So most of them we should be prepared for. Integration, just generally, if they don't have numbers on the integrals like these, you have to have that plus c. So here we go. X to the third divide x squared divide, and gets an x, and then plus c because it's not a definite integral. This is an indefinite integral. So here I get to split the numerator. So this is in essence x to the fourth over x to the third, and 8 over x to the third. So kind of think of it like this. So this is this integral is of x plus I'll start a new integral here. Plus 8, 8x to the negative 3. So I rewrite it. So I split that numerator, and now I can go to work. So this is x squared 1/2. And this is x to the negative 2. Again, divide. Okay, this one's not a big deal. 5x, e to the x is e to the x. Okay, here they give us a derivative, and they want to know what is the particular solution. That means what is f of x, just straight up. No c's, what is f of x? So the integral of that is going to get you f. And so that's x squared divide negative 3 plus c. Here's where the initial condition comes into play. So they give me x of 1, so negative 3, 1 squared plus c. That's going to be equal to negative 2. So that's negative 3, so that'd be plus 3, so that's positive 1. So f of x is equal to negative 3x squared plus 1. That's the particular solution. Okay, here they start us off with the second derivative, not a big deal. So the integral of that will get you the first derivative. And so that's x squared divided by 2 is 12. They give you an initial condition with that of negative 1. That's equal to 7. Negative 1 squared is positive 1, so that's positive 12 divided by, minus 12 is going to be equal to negative 5. So the first derivative of this dude is 12x squared minus 5. Okay, that's not the particular solution. Again, the particular solution is the original f, not a derivative. So taking this one more step, the integral of this is x to the third divided by 3 is 4 minus 5x plus its c. They give me a condition of f of 1. So f of 1 is 4, 1 to the third minus 5, 1 plus c is equal to negative 4. So this is what? 4 minus 5, that's negative 1. So that's going to be a plus 1. That's a negative 3 to you and I. And that leaves that f of x to be equal to 4x to the third minus 5x plus c, which is a minus 3. That's your particular solution. All right. Ball is thrown vertically upward from the ground with an initial velocity of 96 feet per second. Use an acceleration of negative 32 feet per second. That's, yeah, acceleration, that's gravity. All right, so initial velocity. So initial velocity means at time 0, the velocity is equal to 96. Okay, how long will it take to rise to the maximum height? Again, as I kind of described before, is this. If I throw a ball straight up, its velocity will start off really large, but then it'll slow, and then the velocity will turn into 0, and then it'll be negative on the way back down. So it starts off big time positive, and then the positives get slower and slower and slower, and then it's negative, 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 negative as it hits the ground. So when the velocity is 0, okay, when the velocity is equal to 0, that is the maximum height. And what you can do is you can elicit a time at where that occurs. Okay, but we're forced into starting with the acceleration. So the acceleration in general is negative 32. So the velocity is the integral of this, and that's negative 32t plus c. All right, so this is where we use that initial velocity. So the initial velocity implies that time is equal to 0. And that's equal to 96. So this constant that was created is 96. Thus, the velocity is negative 32t plus 96. All right. As I was saying, how long will it take the ball to reach the maximum height? Actually, let me take this equation just one more time. Let me just go one step further and turn this into a position, and then I'll answer all the questions. So this is a big equation right here. This is a big equation right here. And now let's go ahead and find the position, which is the integral of velocity. So this is negative 16 t squared plus 96 t plus its c. All right, so this was thrown upwards from the ground. So that means at time 0, the position was 0. So at time 0, the position was equal to 0. Plus 0. I know you probably don't have all this room on your paper, but use the board and I'll explain. All right, so that's another big one right there. So you got acceleration, velocity, and position. Those are complete equations. All right, how long will it take the ball to reach the maximum height? That is saying, how long will it take for the velocity to equal 0? Oh, it should have been negative 32. So that'll take 3 seconds to reach the maximum height. What is the maximum height? That's a position. So what is the position at that 3 seconds? That's 144 feet. Let me change my labeling of this a little bit. Sorry. Let me include that in the notes as well. So how long will it take to reach the maximum height? It'll take 3 seconds. What is the maximum height? That's 144 feet. How long will it take, how many seconds is the velocity, excuse me, after how many seconds is the velocity of the ball 1/2 its initial velocity? So that means the velocity, how long will it take to be equal to 1/2 the initial velocity? So the initial velocity was 96. So when is the velocity 48? Because the ball's going to slow down. So when is it 48? What is the height of the ball when the velocity is 1/2 the, okay, so that is, what is the position? And again, the position formula, oh, there it is at the bottom, very bottom blue one. It's 108 feet. All right, find the sum. I'll write it the long way here. I'm sorry, this should have been a minus. All right, so this is what? 2, 7, 12, 17, 22. I can double verify by making my stat equal to 1, 2, 3, 4, 5, and I can take the sum of 5, list 1 minus 3. It is the same. Write this in sigma notation. So it looks like we start at 1 and go to 10. So that means I is 1, sigma goes to 10 of 1 over 3i. Find the definite integral using a geometric formula. So that means these are going to be creating shapes. So here, this has a y-intercept of 5. X is positive 5, so it's moved over 5. It's going to be like that. And so this has a height of 5. This is at 0. This is at 10. Just going to quadruple check to make sure I'm right here. So that's 5 minus the absolute value of x minus 5. Yeah. And so they want to know what is the integral from 0 to 5. Ooh, some 0 to 5, not the entire thing, but 0 to 5. All right, so this is going to be 1/2 the base times the height. Okay, this is again half circle. Positive half, more specifically, with radius of 6. So 36 divided by 2 is, what, 18? Okay. I don't know if we really talked about these a whole lot. So an integration is still an integration, even if there's a plus sign in the middle. So this would be 4 to 8 of f plus 4 to 8 of g. So 4 to 8 of f plus 4 to 8 of g. Same with minus. Okay, it doesn't slow down integration at all. So 4 to 8 of f minus 4 to 8 of g. So multiplication doesn't slow it down. So 2, so this is a 2 integral minus a 3 integral. I'm using what those values are though. So 2 4 to 8 of f minus 3 4 to 8 of g. 24 minus 15. Again, 4 to 8 of f. 4 to 8 of f is 7. 4 to 8 of f, 84. Okay, okay, I don't think this was ever in any lesson, so let's learn it now. This is the lower bound and this is the upper bound. So like, for instance, if I'm taking an area of this shape right here, they want to know what is the area from the lower bound to the upper bound. Okay? And so what you do is you take the integral of the upper minus the integral of the lower, and that will give you the area between the lower and the upper bound. Now, what happens if you say it backwards? You say upper bound, lower bound. All right? Well, yes, you're still going to get that area, but it's going to be negative. It's going to be negative. So, for instance, if you were supposed to be taking 6 minus 3, this would be the upper bound minus the lower bound. Okay, that's all fine. You're going to get an area of 3. But what if you accidentally entered it as lower bound minus upper bound? You would get an answer of negative 3. So what I'm saying to you is this. The order matters. So here, for instance, they set it backwards. You're going from 6 back down to 3. So that's fine. You're going to get your answer. But this is the same thing as saying negative the correct order. Okay? That's the same thing as saying negative the correct order. All right? I know I mentioned this a little bit before about question A. If I'm going from 0 to 6, you can break that area up into smaller bits. So 0 to 3 and 3 to 6. So again, the concept is this. If I want to go from 0 to 6, okay, if I want to go from 0 to 6, that's the same thing as taking 0 to 3 and 3 to 6. That's the same difference. An integral evaluated at the same upper and lower limit. Again, this is area under a curve. So if I have a curve, okay, and I have a value of 4, what's the area if the upper limit is 4 and the lower limit is 4? What's the area of that line? It's obviously 0. Okay, there is no area of a line. Lines don't have areas. And then this one is just, you're able to take out multiplication nodes. Okay, that is the idea behind all of these. All right, so let me write it a little bit better here. So 0 to 6 is equal to 0 to 3 plus 3 to 6. This is a very shorthand version of it. And so 0 to 3 I see is 4. 3 to 6 is -1. So this is going to be equal to 3. Okay, 6 to 3 is the same thing as a -3 to 6. I couldn't have written it better right there. And so -3 to 6 would be -1. So that's going to be equal to a +1. Integral evaluated at the exact same point is just straight up equal to 0. There's no reason to even do the integral. This I'm allowed to take out the constant. That 3 to 6 was equal to -1. That 3 to 6 is equal to -1. Okay, here is where we start our definite integrals. Okay. So they said this backwards, but if you just do the integration, again, make sure you take the 0 before the 4. Because technically what you should do is take the -0 to 4, low to high. All right. But I'm not going to mess with that. And this is an x times an x to the 1/2. So in multiplication, you add. Multiplication, you add. So this is the same thing as saying x to the 3/2. Again, I know it's written backwards. If you hate this, you can go ahead and turn it into 0 to 4. It's the same thing. It's the same thing. Because the integral is physically written backwards. All right, so this is x to the 5/2 evaluated from 4 to 0. So that means you evaluate the 0 before you evaluate the 4. So 4 to the 5/2. So that'd be 2 to the 5th, which is what, 32? I just want 4 to the 4 to the 5/2. Yeah. All right. Now again, you would have gotten the same answer if you would have done it this way, because this again is 5/2 with an outside negative of 0 to 4. So evaluate at the 4 minus evaluate at the 0 with an outside negative. That still is equal to negative 32, no matter how you slice it. So if you wanted to do it that way, you can absolutely do it that way as well. All right, x is x squared, e to the x is e to the x. So 2 is 4 is 2 plus e to the 2 minus 0 is 0 plus e to the 0, which is 1. So this is e to the 2 plus 1. Okay, 8 minus x. Okay, would be from 0 to 6. So this technically would be a rhombus, or it's a trapezoid. Anyways, I think they want us to do it with integrals. So this, find the area, so that would be the integral from 0 to 6 of 8 minus x. So 6 going in, 8x minus 1/2 x squared is 30. Plug it minus the lower limit 0, 0, 0, 0, 0 is 30. Again, this would be a height of 6 with a base 1 of 2 and a base 2 of 8. So that is a trapezoid. So that'd be 1/2 the height of 6, base 1 plus base 2. So you could solve it geometrically if you really needed to. A 2/x, again, is one of these swoopy swoop pictures. This is going from x of 1 to 3. All right, so this is going to be an integral from 1 to 3 of 2/x. So I can take out the multiple and just take that. This is going to be an ln, by the way. It's right below here. So this is 2 ln of x, 1 to 3. So that's 2 ln of 3 minus ln of 1, which is 0. So this is 2 ln of 3. The average value, that means the rectangle is equal to the curve. The rectangle is equal to the curve. So the rectangle has a base from 4 to 9, so that's 9 minus 4, that's going to be 5. And that is the average value right there, f of c. Okay, and then we also, in the question, we find all the values of x in which the function equals the average value. So, okay, we'll get to that. And then, so this is going to be equal to the curve, which goes 4 to 9, and that's x to the negative 1/2. All right, so this average value is going to be a 1/5. This is x to the 1/2 multiplied by 2, evaluated from 4 to 9. So this is 2/5 times 3 minus 2, square root of 9 minus square root of 4. And so this is going, this average value is equal to 2/5. Okay, but that's not the entire question. So we found the average value. So find the average value of the function over the interval. And then any values of x on the interval for which the function, that's the function, is equal to the average value. So in essence, we're finding these values of c. And they're going to be on the interval from 4 to 9. So we are in essence finding the function. Where is that equal to this average value? So we cross multiply. And then square. Is that what is it for? 3, 8, 4, 4, 5, 6, 6, 6, 6, 6, 6, 1, 2, 5. Notice how that's on the interval from 4 to 9. So this is a value c, which has to be on the interval from 4 to 9. It has to be on that interval. Second fundamental theorem of calculus, that means when I take a derivative and it matches the top, all you have to do is replace the things with x's. And so we are finding f prime, which is the derivative of this f. So that's just straight up going to be x squared, 1 plus x to the third square root on that business. Again, the derivative of x, it matches that top, so we're good to go again. Find the indefinite integral. Here with all this complicated stuff, you're probably doing U substitution, which we are in this case. All it costs us is a 1/3. again, this is a chain rule. It doesn't look that complicated, but this is a chain rule, and we're not allowed to do chain rule kind of ideas. So again, revert back to U substitution, and it'll take care of itself. Because this is a definite integral, we're going to reevaluate the limits before we do anything. So 1, again, you plug it into U. So 3 times 1 plus 1, 0 times, 3 times 0 plus 1. So I reevaluate the limit, and it's going to cost us a 1/3 to do this process. So this is going to be a pretty big number. So 4 to the 6th is 4,096 minus 1 to the 6th, which is 1. And that's going to be a 1/18 of whatever that is. Hopefully our calculator can handle it. All right, this next one is the one that we have to get swifty if you're a Rick and Morty fan. We have to get pretty clever with this number 77. All right. So, and the reason that we have to get clever is because if I said, hey, I want U to be 2x plus 1, the derivative of that is 2, but I don't have a 2. All right, I don't have that. So, oh, no. I'm sorry. This is not the one that we have to get super clever with. Ha ha ha, because I'm going to split the numerator. I'm sorry, I'm getting ahead of myself. There's one that we're going to have to get crazy clever. All right, this one is not. So this is going to be 1 to 4 of 2x over 2x plus 1 over 2x. So this is 1 to 4 of 1 plus 1/2 x to the negative 1. I'll split that into 2 separate integrals. I'll do the 1, so that's going to be x. And x to the 1, negative 1, that's going to be ln. So this is going to be 4 minus 1. And this is ln of 4 minus ln of 1. And so this is going to be 3 plus 1/2 ln of 4. Okay, this is not going to be the answer that you're going to see in the book, because again, the concept is a ln of b is the same thing as saying ln of b to the a. And this 4 is the same thing as saying ln of 2 to the 2. That's 4. So this could be 2 ln of 2. Again, these numbers don't have to be the same, but they just happen to be this way. So this is ln of 2 if you think of it that way. And so 1/2, this is the 3 plus ln of 2. So again, I don't mind if you give me this previous answer or this answer. Either one, it's all good to go. It's all gravy to me. It's just if you don't see your answer on an answer guide somewhere, that's why. Okay, velocity, they want to know average velocity. Average velocity, so that's rectangle is equal to curve. So the rectangle is from 2 to 0. And so this is 0 to 2, or excuse me, 0 to 2, I should have said, of the velocity. And so the velocity is given up there. So this average value is going to be t to the 4th, 1/4 minus t squared, 0 to 2, and then I already divided. 2 minus 0 went over. All right. So this is 1/2 2. Technically no technology, so let me not use technology. 2 to the 4th is 4 times 4, that's 16. 16 minus 8, that's 8. Minus 0 is 0, so this is 4. Okay, a pot of coffee cools down at the temperature. The coffee is modeled by blah, 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 where T is measured in time. That's temperature, et cetera, various temperatures. Explain what that means. That's an average right there. That's an average, average temperature. Again, this is the rectangle. Okay, the rectangle is from 12 minus 0 of the average is equal to the integral of the temperature from 0 to 12. And so all they did is they divided over. And so this is the average temperature. That's what that means. That's an average temperature. In context, we use the trapezoidal sum with 5 subintervals to approximate that. Okay, so explain what the meaning of that is, the context. So 1 over 12, 0 to 12 CT dt is the average temperature in degrees Celsius of the coffee from 0 to 12 minutes. Okay, so they want me to do that. Okay, and so again, what these trapezoidal sums do are just the integral. It does not take the 1/12 into consideration. So if I need to take an integral, that is the same thing as taking one of these like left sums or right sums or midpoint sums and things like that. Okay, these bases of 5 intervals. So this is going to be interval 1, interval 2, interval 3, interval 4, interval 5. Notice that these intervals are not the same. This interval is 3, this interval is 2, this interval is 2, this interval is 1, this interval is 4. So I cannot shorthand it in, like, singular the 65, singular the 40, and double all the end limits. I can't do it that way because I don't have a consistent height. All right, so here's what this is going to be. This is going to be 1/12 the trapezoidal approximation. It's going to be 1/12 the trapezoidal approximation. So this is going to be 1/12 the trapezoidal approximation. So I'm also taking out a 1/2 to help with the trapezoidal approximation. So consider everything to have a 1/2 on it, and that's fine. Okay, so the first one has a height of 3 and a base 1 of 65, base 2 of 57. Next one, 2 with 57 and 50. 2 with a 50 and a 46. 1 with a 46 and a 44. And a 4 with a 44 and a 40. So here we go. This is 3 with 65 and 57 plus 2 with a 57 and a 50 plus 2 with a 50 and a 46. Plus a 1 with a 46 and a 44. Plus a 4 with a 44 and a 40. Excuse me, 40. All right, so that's all that inside, and then the outside is a division of 24. It makes me feel like I got the problem wrong. This is my average temperature of coffee. I don't know if I got that on my answer key or not. I don't have my answer key right in front of me. Take a quick glance. Answer key that I did get. Hopefully it's consistent. What do you know? It's exactly the same. Better than I thought. What do you know? So that's the average temperature of coffee, and that's, 50 degrees. That's the ball game.